calculus kids. This is Dr. Callahan with week 7 Thursday. How are you guys doing? Go ahead and pause the video and answer the following 3 questions for your warm-up log. Keep in mind that it is due on week 9 Friday, so this is week 7 Thursday, so you have exactly about 11 days until it is due. Or I should say 11 school days until it is due. All right, let's go ahead and start the assignment for this class. So this is for week 7 Thursday. Here are your instructions. Make sure you check in with me by 9:41 a.m. for your attendance, because I have to take attendance prior to that during that period. So just make sure you guys do that. Our topic of discussion today is going to be on integrals with trig inverses. Last class, keep in mind that we talked about derivative with trig inverses. So this will be the opposite of that. AP Calculus AB, semester 2. And this is, of course, is due by 3 p.m. So I'm just gonna go ahead and click assign. All right, let's go ahead and get started with today's stuff then. Here's a breakdown of what we're going to be talking about today. Let's go ahead and take a look at your guided notes for today. So turn over to week 7 Thursday. This is going to be the first page of Thursday. Second page of Thursday. This is specifically where we're going to have your questions and your guided notes. So make sure you have this page in week 7 Thursday. And then I'm also going to give you the information of how to get onto Albert.io. If you're doing this at home with hybrid, make sure you just log on to Albert.io and then type in the class enrollment code right here. Keep in mind that your Albert.io is going to be 10% of your grade for the second semester. So make sure you guys complete this. Specifically, you can go ahead and get started with it if you will like, whenever you will like. But when we are done with Math Excel, Albert.io will take over for the remaining 3 weeks prior to the AP College Board exam, or AP Calculus exam. So do keep that in mind. All right, so with that said, let's go ahead and start today's lesson. So we're going to go ahead and get started right over here. Take just a second to go ahead and read the 3 formulas that are highlighted in green. Keep in mind that the 6 on the left in yellow are derivatives that we've already gone over in the last couple of days. Okay, so for example 1. Well, if you take a look at example 1, you gotta ask yourself, which one of 1, 2, or 3 is example 1 most likely going to fit? I can say that it's probably not going to fit number 2 because there is a plus sign right there. And given the fact that you have an X on the outside, it looks like it fits number 3. So let's go ahead and start this. So let's go ahead and say let U, and if you just go ahead and match this, U is going to be X. So then your du is just 1 dx, and then your dx is du. And we're going to go ahead and rewrite this. So that in addition to the dx equaling du, also take a note that a squared is equal to 9. So that a probably will have to be 3. And you want that because notice that you have a here, and u here. So we would need to have that piece as well. So let's go ahead and rewrite that. Integral of 5 over u square root u squared minus a squared is going to be the same thing as, if I go and put the 5 on the outside of this, 1 over a is the same thing as 1 over 3 arcsecant u, which is x, over a, which is 3, plus c. So then my answer could be 5 over 3 arcsecant x over 3 plus c. And that is your answer. Let's take a look at example 2. So with example 2, once again, you're going to try to go ahead and match this equation as closely to 1, 2, or 3. And as I'm looking at this, it's a plus right here. So immediately what that tells me is that it's probably going to go with 2. Now, components of this requires you to have a u and an a. So let's make sure we have an a and a u. And if you look at this right here, let's go ahead and match them as closely as possible. Here you have a squared, which is 4, plus u squared, which is going to be x minus 1. So as such, we can go ahead and say, let u be x minus 1, which means then your du is going to be just 1 dx. So du equals dx. All right, so now that we've established that, we also know that a is equal to 4, or a squared is equal to 4. So then a is going to be equal to 2. So you have the integral of 1 over a squared plus u squared du, because we're replacing the dx with du. Now that's the same thing as 1 over a arctangent u over a plus c. So let's go ahead and replace it then. So that's 1 over a, which is 1 over 2, arctangent u over a, which is x minus 1 over a, and a is 2, plus c. And this is your answer. All right, let's go ahead and take a look at example number 3. That's just a little bit blurry, so I'm going to see if I can just give me a second so let's see if I can fix that a little bit for you guys. Oh, no, I don't like that. That doesn't look good. Well, I think that's as best as it's going to get, but that's okay. I could deal with that. Okay. So once again, you're going to try to match this with 1, 2, or 3. And which one do you think is the closest to? So looking at the bottom here, I would say that because the x is right here for x squared, most likely it's going to match this one because there's a minus. And a is generally going to be the constant, so like 7. Okay, so in this situation, you have a square root of, and I don't have actually put the square root, I could just put a squared minus u squared. So it's pretty obvious that your or u squared is negative 16x squared. Or actually, I should just put 16x squared. Sorry, forget the u, or forget the negative. Then u is going to be 4x. Your a squared is equal to 7. So a is a square root of 7. And then you can say, let u be, well, your u is already going to be 16x squared. So u is 4x. So then u prime or du is 4dx. So then dx equals du over 4. So then at this point, let's go ahead and rewrite this equation. So I have the integral of 1 over square root of a squared minus u squared. And if I replace the dx, I'm going to go ahead and have a du over 4, which is going to be the same thing as arc sine u over a plus c. So my answer is arc sine u, which is 4x, over a, which is the square root of 7 plus c. Oh, and don't forget your 1 over 4 here. So let's put the 1 over 4 back. And that is your answer. Okay, let's take a look at example 4. Example 4 is how you're going to use the inverse of trig integral rules with completing the squares. And I have included the 4 different steps here that you guys can use. So for now, go ahead and read this part and then also read the 4 steps. And just take a moment and see if you remember how to do completing the square, going back to Algebra 2 Honors. Okay, so first things first, as you're looking at the example 4, notice how the denominator doesn't match 1, 2, or 3. So algebraically, you're going to go ahead and try to make it match one of them. But, right now you have a trinomial. You need to have a square. So let's try to maybe complete the square. So with completing the square, there are 4 different steps. Step 1, write it in standard form. And it's already in standard form, x squared minus 6x plus 13. Step 2, add a space, x squared plus bx plus space plus equals. I guess you could say plus c and then minus whatever you're going to add here. So let's do that. So x squared minus 6x plus blank plus a 13, but you're going to have to subtract that blank because you're balancing it on the same side. So on the same side where you're going to add it, you're also going